So in this module, you were looking at the flow of energy through ecosystems. And so what I would like you to look at next is we prepared a module for Biology 101 that deals with the cycling of nutrients within ecosystems. So please take a look at this module. I want to continue our discussion of ecosystem dynamics today, as well as management of both ecosystems and species within ecosystems. So one of the important dynamics that we see within ecosystems is certainly that of the matter of ecosystems, the molecules, especially those that are important to life. And so as we've talked about before, matter recycles in ecosystems, so the atoms and molecules of which you and I are composed essentially are as old as the Earth itself. But it's the energy, of course, that passes through ecosystems that cannot be recycled, but the matter can. So when we look at these biogeochemical cycles then, there are certain common features that we see to them. And one is that for a particular important element, for example, nitrogen or phosphorus in particular that we're going to talk about, but carbon, oxygen, and others as well, there'll be some form that's useful to living things. And this useful form then will be assimilated by plants or taken up by plants, and then through the food chain passed to animals. And so basically the producers will take it up and pass it to consumers. So it doesn't have to be plants necessarily, it can be other types of producers. And then both plants and animals can die, and in their dead form we refer to dead plants and animals as detritus. And also animals will produce waste. And then these nutrients then are locked up in the decomposing tissue and the waste of plants and animals. And then decomposers, microorganisms, typically bacteria, archaea, and fungi, will decompose those organisms and return the useful form to the environment. So again, this could be an aquatic ecosystem, this could be a terrestrial ecosystem. So they continue to cycle then, through the food chain in this way. Now, what can happen is that sometimes this useful form, though, gets trapped in sediments, marine sediments or aquatic sediments, and essentially then they seemingly are out of the cycle. But the reality is, are they out of the cycle? Well, they're not out of the cycle forever. So basically, once the nutrients are trapped in sediments, what can happen is that the sediments, or what will happen is that the sediments are buried, and literally they can be miles deep, into the ocean floor. But eventually they will get back to the cycle. They'll eventually get back to the surface. And the way that they're going to get back to the surface is through geologic uplift. So, crustal plates, can crush together and then ride up over one another and eventually reach the surface and then be eroded and return that nutrient back to the ecosystem. Or also, they can also what we call subduct. The plates can actually one plate can be pushed under another. Eventually, that rock and sediment will melt and then be part of volcanic eruptions. So again, they might be out of the cycle for billions of years, but eventually these nutrients do get back into the cycle. So really nothing is ever out of the cycle. Eventually it has the potential to be reused again. So we're going to look at a couple of cycles, a few different cycles, and the first one is the nitrogen cycle. And the nitrogen cycle has kind of a cycle within a cycle in a sense. But when we look at the nitrogen cycle, we begin with nitrogen, N2, nitrogen gas. And nitrogen gas is really not a very friendly or useful form of nitrogen for living things. And so what happens is that nitrogen can be fixed by certain types of bacteria, nitrogen-fixing bacteria. And the term fixing normally means either converting it to a useful form or attaching it to a carbon. And so in this particular case, what's going to happen is that nitrogen-fixing bacteria will reduce the atmospheric nitrogen into ammonia or something called ammonium. And then nitrifying bacteria will convert that into either nitrites, NO2, or nitrates. And then these nitrates and nitrites can be assimilated and picked up by plants. So again, the useful form, some people will consider ammonium the useful form, but certainly the nitrates are useful forms, and those can be assimilated by plants, and nitrates are important in the production of amino acids for proteins. So then, once the plants have assimilated them, of course, they can be eaten by animals. Animals have their waste, they can both die, and eventually decomposers can return those nitrates to the soil again. So one cycle is that basically the nitrates will recycle basically through the food chain. Now the other aspect of this is that if you look at atmospheric nitrogen, it seems like there would be a net loss of atmospheric nitrogen, and about 80% of our atmosphere is actually nitrogen. So there would be this constant loss of N2 from the atmosphere. if this was the only process ongoing. So nitrogen fixation takes nitrogen out of the atmosphere. However, there are also denitrifying bacteria which can take nitrate and regenerate atmospheric nitrogen. So again, the denitrifying bacteria will regenerate atmospheric nitrogen. The nitrogen fixing bacteria convert it basically to ammonium, and eventually it will go to nitrate. So once it's a nitrate, again, it can cycle within the food chain, and decomposers will return it to the ecosystems. But again, we also have the cycle of atmospheric nitrogen being taken out and being regenerated again. And then one other factor in nitrogen cycling is lightning. Atmospheric nitrogen can be affected by lightning, and actually that can oxidize it to produce nitrates as well. So in some ecosystems, lightning actually produces a great deal of the useful form of nitrogen, being nitrate. Okay, now another important element, a limiting element in life, is phosphorus. And here the useful form of phosphorus is phosphate. Unfortunately, phosphate is a very stable molecule, so it will pretty much work through the kind of cycle that we talked about earlier. So phosphates can be taken up by plant roots, again assimilated by plant roots, basically work through the food chain and then be reassimilated. Phosphates also then will wash into sediments, and phosphates are again very stable. So these are elements that are again a form of an element that can be trapped in sediments for a long time and then eventually returned either through uplift or volcanism. So again, I'm more or less focusing on terrestrial ecosystems, but again, these nutrients can cycle in aquatic or marine ecosystems as well. The carbon and oxygen cycle we have talked about, at least to some degree, when we talked about photosynthesis and the cellular oxidation of glucose. And anyway, basically, if we look at carbon in the form of carbon dioxide is pulled out of the atmosphere through photosynthesis, and that becomes organic molecules of plants, and that'll work its way through the food chain. And then animals, of course, will practice the cellular oxidation of glucose, returning carbon dioxide back to the atmosphere. So carbon is taken out of the atmosphere by the plants. It's going to be returned to the atmosphere by animals. But of course, also any kind of combustion, any kind of burning, the burning of fossil fuels. Fossil fuels, used to be vegetation at one time. Also, burning of our forests, clearing forests for one reason or another, also will return that carbon to the atmosphere in the form of carbon dioxide. And then, of course, plants generate atmospheric oxygen, although oxygen is not really listed on this cycle, but plants generate oxygen through photosynthesis, and animals will consume the oxygen in the cellular oxidation of glucose. And of course, oxygen is also consumed through combustion, and also decomposition also consumes oxygen as well. So again, that relates to those two cycles we talked about earlier in the course. Water cycle is pretty straightforward, but of course water is very important to life. But basically water evaporates either from the oceans or seas. It cools, it condenses, it falls in the form of precipitation, either snow or rain. Then it runs off the surface back to the oceans or percolates into the soil and eventually works its way back to the oceans. Now, an exception to that, and again, kind of talking about that runoff then, the continental divide here in North America basically separates water that's going to drain into the Pacific as opposed to the Atlantic. And then also a basin, a continental basin, is a place where water, instead of running to an ocean, is going to run to the interior of that continent. So here in North America, we have the Great Basin, and the Great Basin basically is bordered on the west by the Sierra Nevadas, on the north by the Cascades, on the east by the Rocky Mountains, as well as a little bit to the south, and then also the high deserts. And so what happens then is that within that area, which is basically the states of Utah and Nevada mostly, water drains to the interior instead of draining to the oceans. And the Great Salt Lake is a remnant of a gigantic lake that once existed, basically covering Nevada and Utah. So again, basins would be one exception to this idea that all water eventually works its way to the oceans.